Alrighty, everyone, welcome back. I hope we're on our third final day of develop. You're all suitably caffeinated. Probably your social energies are low, but stick with me. This is going to be a bit of a wild ride. Thank you very much for joining me for this talk, a hype-free examination of generative AI in video games. As stated, this is a high-level overview of generative AI, but I wanted it to be useful in a way that's grounded, gives you all useful information to take away for your own projects. Critically, I also felt it was my responsibility, as you'll discover in a second. I have a bit of experience in this space, and I wanted to share that with you in a way that is practical for yourselves. It was a little difficult coming up with the title of this presentation. I originally wanted to call it this, but I had a sneaking suspicion that Develop would not be a fan of that. And then also, given the tone of some of the talks last year, I thought maybe this was a better tone to kind of hit for this particular one. Also, just to kind of manage expectations, I wrote this one, had a good laugh, and then threw it out. And then lastly, I thought the one that just represents everyone's feelings on the subjects right now, just internally screaming for the next 20 odd minutes. Quick introduction, I'm Dr. Tommy Thompson. I run AI in Games, a company that runs consultancy services on artificial intelligence technologies in game development, ranging from research consultancy, development support for programming and design teams, and communication projects, both to customers and other stakeholders across the sector. I work also in professional training under my Goal State banner, and we are running a Kickstarter later this year to build more online resources to allow studios and students to learn better how to interface with games technologies. But to the wider world, I'm a YouTuber, I'm now in my 40s. That's a really bitter pill to swallow. But for 10 years now, I've been delivering monthly updates, detailing the fundamentals of AI technologies, explaining the inner workings of many a AAA title, and also the impact of research in the space. It has amassed an audience of over 250,000 people, 13 million views and counting. And so yes, to the wider world, I'm a YouTuber. Don't forget to like and subscribe. I've lived a bit of a charmed life, that's for sure. I was an AI researcher and academic for close to 15 years. I've been a gameplay programmer, a game designer, a technical director. I'm on the advisory board for the AI Summit. You don't need to read all this. The thing I want to take away is I've been in the space for 20 years and I didn't rapidly shift my LinkedIn bio 18 months ago to catch in on the new hype. Apologies to anybody who's working on Web3. So what's this talk about? Come on, we're going to do a little primer on AI for games. When we're talking about AI, what do we actually mean? Next up, an overview of generative AI, very much in a nutshell. It's going to be very high level and technical, but hopefully enough that you might actually get something extra out of it. And then largely some considerations for applying it in your own projects, whether you should, whether you shouldn't, and what are the big issues you need to be aware of. So, a primer on AI for games. Right now, a lot of people inside our industry and outside our industry have got opinions on what is and isn't AI. Fun fact, most of them are wrong. And also, I will happily fight them out on the waterfront afterwards. We're all friends here, but, you know. So let's set the record straight. For the vast majority of the industry, when we are thinking about AI, we are still largely thinking about what we collectively call game AI. Classic game design problems of non-player character behaviors, navigation systems, experience management problems, turning off our phones in the middle of presentations, or at least silencing them. Game AI is a term that was derived largely in the late 90s and early 2000s because academic research did not actually understand or respect the work that was coming out of the games industry. And as a result, there needed to be a terminology for that specifically. And to this day, when we talk about AI for games, when we're 95% of the time, this is still what we're talking about. Technological innovations that occurred in key games such as Doom, Half-Life, and Fear, finite state machines, goal-driven finite state machines, and finite state machines with goal-oriented action planning, just off the top of my head. These are the things that we're still trying to work on for every big game we're working on. How does our NPCs not suck, right? But this landscape has begun to change quite drastically, certainly for the last 10 to 15 years. Since the early 2010s, we began to see something what I refer to as a silent revolution in the industry, as many studios use the latest innovations in machine learning and critically the birth of what we now call deep learning. Now, by and large, when people think of deep learning, we think of the work that was done by Google DeepMind, of training bots that could learn to play Atari games, or even learning to play the likes of StarCraft 2 at a grandmaster level. These are really impressive technological feats. They are also very bad examples of how you actually employ deep learning within a video games production. I don't have time I could make an entire talk about how cool this is, but also how just it does not reflect production practice. But we have seen a lot of innovation since then, as a lot of very smart people across the sector have begun to figure out ways to start interfacing this into our productions. So off the top of my head, previously we already had Forza's Drivatar rely on machine learning. It is now built on a deep learning pipeline, as well as Sony AI's Sophie that is deployed in Gran Turismo 7. We also have the likes of motion matching technologies used in everything from The Last of Us Part 2 to FIFA, and pretty much every major AAA game is trying to figure out how to do smoother animation blending. We have toxicity detection in the likes of Call of Duty, but also we use deep learning and machine learning technologies for matchmaking in a variety of different ecosystems, ranging from Dota 2 to the Xbox network. Texture upscaling when we're trying to remaster classic games, such as the Mass Effect Legendary Edition. This was done as part of the process of developing that game. They used generative adversarial networks to upscale all the textures, or doing it in real time. For example, in God of War Ragnarok uses a neural upscaling technology to reduce the install size of textures on your PlayStation. Because yeah, having just Call of Duty and God of War on your 500 gigabyte hard drive is a little depressing at times. Also, we look at for things like gameplay balancing. So, for example, finding navigation bugs in games like Rainbow Six Siege, or actually doing balancing on changes to the meta in titles such as For Honor. These are projects that Ubisoft La Forge have invested significant time and effort in. And of course, any of you who have an NVIDIA GPU and have been running DLSS, which is deep learning super sampling, it's a real-time upscaling technology. So the reality is AI in games is far more nuanced than it was even 10, 15 years ago. If you want a copy of this diagram, a QR code will be available at the end of the presentation to give you copies of it, and also an article and a video that goes through it in detail. So for most gameplay experiences, NPC, strategic importance, etc., we're still relying on practices from 20 years ago. That hasn't really changed. But also, we're now seeing a lot of other AI technologies get deployed across the sector. But of course, in 2024, the conversation is generative AI. So I want to unpack what this is, do a little bit of myth busting, how it's actually being adopted in different parts of the sector, and then later on, we're going to get into the challenges and risks inherent with its adoption. So, my apologies if you haven't seen Avengers, this joke's going to fall flat, but I wanted to break this down into 4 key areas and really just set the stage for everyone, make sure we're all coming into this with the same level of knowledge. What is generative AI? Generative AI is actually a specific subset of algorithms that train models to create new content that is evocative of the material that it was trained upon. So for example, text generators like GPT create text because they were trained on text. They learn the inherent properties of written language and then find ways to reproduce it. Similarly, image generators like Midjourney, DALL-E, and Stable Diffusion generate images by training on images. Legality of all this, we'll come back to that later. But it's important to understand that generative AI is really just a subset of a lot of stuff that already exists. So generative AI is really a subset of deep learning, which is a subset of, it's turtles all the way down here. You'll notice game AI is actually off in its own little corner because it is a very specific subset dealing with very specific practical problems. Now, the reason that I bring this up now is there's 2 things I really want to get across. That, as I said earlier, for some people, the goalposts continue to shift as to what is or isn't AI. Those people are wrong. I will argue that to the death. That is the hill I will die on. And again, we're all friends here, but to say that you don't work in AI because you design behavior trees for a AAA game, that's a load of shite. Second of all, AI is a lot more than the current hotness. I think that's also something, particularly for people interested in investment. There are so many application areas that we are not exploring with this technology that would actually solve pain points that exist in our practical pipelines across the industry that is not being explored. And it makes me very annoyed, but I only have so much time. So yeah. How is generative AI, right? This is the most technical slide, don't worry. It'll all be over soon, just hold your breath. Generative AI is heavily reliant on what we call neural network architectures, which is the left-hand side there. These are a series of mathematical models where we have these individual processing units, neurons typically that we refer to them as. The ones in the middle there in blue, those are the processing units of this particular architecture. And we process it as a weighted summation function of all of the data that comes in from the input layer into the connection. So all those arrows each have individual weight and value. Now that's the very high level version of it. And what you do is you train the weights, and over time it can actually begin to learn, provided it's been given sufficient data and space to iterate on it. It can learn to come up with useful policies that help us actually solve particular problems across the sector. Now, this isn't really new. Neural networks are old tech. In fact, the first really nonlinear perception was actually single-layer perceptrons date back to around the 1960s. But really the two big things that have led to an innovation in this space are, first of all, in the middle, this is what we call the attention transformer. Well, it's the transformer architecture, but it utilizes what we refer to as attention mechanisms. And this has solved the challenge of natural language processing in a way that we've not been able to really consolidate or be able to understand over the last 50, 60 years of this field. And this is what is powering the likes of GPT. It's allowing it to build a much richer understanding and build embeddings and relationships of text across both small and large scale samples. Also on the right-hand side, that is what we refer to as a diffusion model. So this is how we generate images. You learn to assemble images from noise. And in order to do that, it actually starts with a collection of images and then tries to destroy them gradually by adding noise to them. And by doing so, it actually learns the inherent structure of those images such that it can then reproduce it on the back end. You give it the noise, it can then reverse engineer it into an image. Now, that's the big thing that we really need to do. I just wanted to cover this high level thing. But the critical part here is that all of these generators, image generators, text generators, at their heart are statistical models for the reproduction of data. They don't understand the data they're given. They don't understand the input they're given. They don't understand the output they generate. But often, actually, the quality of them is actually inferred from our own interpretation. So, and this is also why things like GPT, the professional term is hallucinate. My favorite term is talk shit, because they are building a statistically likely output based on the input that it was given. So if you give it a question, such as asking it, how much money did this movie that's coming out, like the Deadpool and Wolverine movie, which is coming out in a couple of weeks' time, how much money did it make in its opening weekend? It will give you an answer that it thinks is likely going to be the output, even though it doesn't know what the input was because the film isn't out yet and it doesn't have the data to learn from it. And that's really coming down to how, in order to do this, we have tremendous amounts of data. One of the problems with generative models is they are incredibly data intensive. Even small large language models, which aren't to be confused with language models, because that was a thing that existed for 50 years before we did large language. Let's not get into that. They require large amounts of data in order to be able to generalize and begin to learn these things at a certain level of quality. And the most effective image and text generators are massive in size as well. This is a big problem. Hence, they often run on web services. Of course, OpenAI, if you want to use GPT, you have to log into their infrastructure. Most of them are running off AWS, last time I checked. They have astronomical computational costs, which is an issue that we have to bring up later on. And again, large amounts of data, whether it was accrued legally, yeah, I don't have to get into that. But remember, statistical models, they're simply reproducing that which they have seen. And so one of the things, particularly with my clients, is it's two parts. One, after initial introduction, I never refer to it as generative. I call it derivative AI, because that is inherently what it is. It's a system that is able to generate new outputs that is highly derivative of the things it was trained upon. The problem is the data is so massive, we cannot often immediately see what it's been derived from, because it's seen more text than any human will ever process, and it's seen more images than any human will in their lifetime. But it means that also it's regurgitating stuff without context, without quality, without inherent understanding. So when I asked it, I want you to produce an image of a robot parrot, because that's what I often think of GPT as, it amazingly managed to do it with 3 legs. Wonder if anybody caught that beforehand. Why is generative AI? Now, I could be cheeky about this and just say capitalism, but the reality is a little bit more nuanced. We have decades of work in text and image recognition and generation that's now reaching a point of maturity that it could be applicable in certain use cases. We have a desire to better understand the capabilities of these systems in a number of contexts, learning what scale of data these systems can handle or require, understanding the challenges. No, actually, it's mostly just capitalism at the end of the day. And we can see that in full force. There are a large number now of generative AI companies making tools for game developers, be it for things like dialogue and story generation, character creation systems and pipelines, image and texture generators, animation generators, 3D model generators, voice synthesis, and music generation. You can, of course, if you're inclined to do so, look into building your own systems as well. A lot of this technology is becoming standardized and being made available in a more open source capacity, but the quality of these tools varies drastically from individual instance to one another. Some of these are not, some of them are actually pretty functional and reasonably competent. Others are simply not fit for purpose. And meanwhile, several are clearly built by people who've never made a game in their life. So please don't tar them all with the same brush. I think this is a critical part of my talk. If you're interested in these tools, you really have to go away and do your research on them. And a lot of them are simply not market ready. A really good deep dive into this, if you're interested, is to have a look at Project Ava, which was an internal R&D project ran across several studios at Keywords. It was led by Electric Square in Malta, who are over in the expo. And they were trying to figure out, could you build a game entirely using generative AI tools? And the game itself is never going to be released because they're fully aware of both of the moral, ethical, and legal issues surround it, but they wanted to do this as an experiment to see how far it can come along. So could you build an entire game using just generative tools? The short answer is no, but the long answer is much more interesting. Stephen Peacock and Lionel Wood gave a really good post-mortem on this, which summarized that they found that they could actually get certain aspects of their production pipeline either speed up a little bit, or actually they couldn't perform any of this in any capacity using these tools. There is a talk that's available in the GDC Vault. It's free to access. It's also on the Keywords website. And I've put a link also to my own breakdown of that talk, if you want to have a look at that as well. So generative AI in actual games, are we actually using it? Now, this is actually a question I get a lot from the press. Like, why isn't generative AI all over games? I'm like, well, you know, the games that are coming out now, we started working on them like 5 years ago, mate. Like, it didn't exist 5 years ago. Especially when you consider this to other sectors, the growth has been small. And again, a lot of it is the risk, which we're going to be using to wrap up this talk. I often see examples break down into 3 specific categories. First of all, tech demos. So here we have Origin, which is a detective game developed by InWorld, who are building their own tool stack. And then NVIDIA's ACE platform, which collaborated with Convey for these conversational characters. You then have what I would often consider spurious implementations. So the voice commentators in the finals are synthesized AI voices, and also the album art in Foam Stars, which was all generated using image generation tools and went terribly for them. That was not a good vibes. Right now, the answer is cautiously. And there's a number of reasons for this. That's going to be essentially the last 4 slides of this talk. Every AAA company I talk to and work with is exploring this technology in some capacity or another. In fact, I'm very much looking forward to the next talk right after me by Martin from Behavior Interactive. And a lot of them are looking at it in ideation, iteration, and some facets of production that often will not make its way into the actual product. And that's really coming down to a lot of intellectual property and legal considerations. And in fact, in some cases, when they use it for early ideation and iteration, which it does help speed up that aspect of production, once we've reached a certain point, the smart thing is to throw it all out and then let the creatives actually do the creative work, because we know we've overcome this particular early phase of ideation. I'd say actually the one exception to this, depending on the studio, is GitHub Copilot for code writing, but also I'm aware that the policies on this vary drastically from studio to studio. There are indies out there that are exploring generative AI, but it's not as pervasive as many would think. Naturally, AI Dungeon took the lead on this back in 2019. And more recently, the larger improvements in generative models and the open source nature of these tools and processes is enabling for other teams of varying sizes to put this together. In fact, Dead Meat, which is up in the top left corner, that's playable right now down on the expo floor. Go and check it out. 1001 Nights. That's also being put together by a bunch of indie devs. In fact, a PhD student, Yuchen Sun, based at Royal Holloway in London. And then you also have weird, wonderful games like Suck Up and Infinite Craft, where Suck Up is you're trying to sweet talk this person to let you in and let you into their house because you're a vampire and you want to get into their house so you can kill them. I also say indie in inverted commas here because 2 of these companies got investments to tens of millions of dollars to go and make their game. So, I mean, the other ones didn't. But, right. Considerations in applying generative AI. And the big thing is, am I going to get sued or am I going to lose my job? I want to address the elephant in the room first and foremost. Generative AI has a significant moral and ethical problem. As I mentioned already, the data required in order to be practical with these systems is often astronomical in scale, and in high-profile cases such as OpenAI, undoubtedly illegal. Like, let's not sugarcoat it. People's livelihoods are being affected by this technology because capitalism is going to do what capitalism is going to do. It consumes a ton of energy and money to maintain and run these systems. GPT-4's training process was estimated to have the carbon footprint equivalent of a gasoline car being driven for 18 million miles. That's just training it. That's not hosting it and running it every day. And actually, these models cost tens of thousands, if not hundreds of thousands of dollars a day just to keep them running on the likes of AWS. While it is possible to employ a lot of these technologies ethically, legally, I also equally understand for many this is simply a no-go. I get it. I'm not going to defend any of this. And frankly, as someone who's been in this space for a while, the situation as it stands makes me unbelievably angry. I'm being very chill about this over the next 20 odd minutes. But it is important to stress that if you are interested in adopting this technology, the issues that I'm about to raise, these become yours. And you will have to actually address these. But critically, at the same time, it's important to grasp that a lot of this, it's a useful tool, but that's all it is. It's a tool. We're the creatives, right? We're the people here that actually make games. The tool doesn't replace the expertise. It's supposed to help expedite the expertise. And I do feel that over the coming years, we're going to begin to have an annealing effect where things are going to cool down as better tools come along to actually solve production problems that we have. And in fact, this is a recurring thing I have when I work with studios. They're like, is there a tool that solves this? Can you get this to do automatic UVs for me? I'm like, no, nobody's made that. I'm like, what do you mean nobody's made that? Surely that's like the one tool they went and made. Like, I know. And then I keep thinking maybe I should go and do it, but I have enough problems. And certainly this perception is massively inflated in the eyes of often upper management and investors, and I try to mitigate that as best I can. Right, important thing. First of all, do your research on what these technologies can do. Some areas of game development either have zero tooling, or it's just terrible. So is there a tool for this particular part of the production? You know, what are the rights to your generated content? If you generate an image with an image generator, do you own it? How is your content used to train a system that you're interfacing with? If you're using a third-party tool that's available to you, you might not even own any images that is generated by it. It is owned by whoever it was that created it. Never mind copyright. We're getting to that in a second. But your intellectual property could be at risk because if you're using your own assets as inputs to the system, they could also be using that asset as part of their training processes. You might be better. So, you might think, I'm actually better off just training my own models. That would be good. But also, if you think you're better off training your own models, what rights do you have to the models that you build? For example, Stable Diffusion 3 has a creator license attached to it that says any image you generate with one of the models or a model that you build off their technology, they own. Also, if you stop paying the license, you have to destroy all the images. You also have to destroy all the models. You don't own shit, but you still got to pay them $20 a month if you want to kind of maybe sort of not quite own it. Also, is the tool, what are the costs and licenses? Costs often become increasingly expansive over time, and particularly if it's going to be generating content that's critical to your game. Excuse me. Most of these tools don't have enterprise licenses. They're monthly costs because they're running on servers. So you have to start baking that in. If you're going to put this game out, what's your server infrastructure for this? How much is it going to cost you to run these tools? And that comes to the other part. Is the tool entirely online or offline? If it's online, you have big trouble. What happens if those servers go down? Does your game suddenly die? If you're using a certain provider and due to regulatory frameworks or politics, it's no longer available, you're also screwed. Excuse me. For example, did everyone know that GPT is no longer available in China? On Tuesday morning, thanks to the American government putting a lot of pressure on OpenAI, as of Tuesday morning, if you're in China, you can't get to use GPT. If you're using a GPT plugin in your game, that game does not work in China. It's screwed. What happens if tomorrow it's the European Union? Right? And there's a good chance that might even happen. So, big thing I'm taking away, go talk to a lawyer. Also, with regards to automation, I was part of a panel on Games Industry Sprint just last month. Go and have a look at that if you're interested in hearing a little bit more on everyone's perspectives and not just mine. Also, copyright. Assets generated currently, US and European laws do not allow for the attribution of copyright to generative AI assets. A human must have been involved in the process. Hence why a lot of studios use it in early ideation, given they can pass it on to a human to then make it copyrightable by actually injecting human creative power. I don't know. Of course, it's fine in China, but since when have they cared about copyright? In the UK, you could, and I do stress, could argue that there's a provision made available by the Copyright Designs and Patents Act of 1988 that could give you copyright on the basis that you wrote the entire generative AI pipeline, you curated the entire data set, and you trained it all locally. But yeah, maybe you should go talk to a lawyer. Platform lot check. Platform submission right now is an absolute Wild West. Steam published their updated guidelines in January. You can find those online. If you're going to have pre-generated or live-generated content that uses generative AI assets, you need to be able to provide sufficient disclosures that what you have done is on the up and up. You need to prove that your generated assets are 100% legally compliant. They're not infringing on other people's assets. Very difficult to prove if you're using a third-party tool, might I add. And new features for catching content generated in real time are going to be rolled out in Steam in the coming months and years. Some games have received approval. Both Dead Meat and 1001 Nights, they're on Steam. Go have a look. But currently, there are no concrete guidance from Nintendo, PlayStation, and Xbox on whether this is permissible. And I also think that, that right now, if Valve's stance is quite strict, you can imagine that also on consoles, it will be stricter. But of course, if it's the Epic Store, just tweet Tim Sweeney, and I'm sure he'll let you on. And then lastly, gaming is a global business, right? Every game that we're shipping, we want to get it out there to as many players as we possibly can. So you need to be aware of the increasing interest in AI regulation that's coming up. So 2 months ago, the EU ratified the Artificial Intelligence Act. It is now going to be rolled out and implemented over the next 2 years. It is the very first of its kind. Other nations will follow. Critically, you have to be able to, if you're using generative AI, prove that it is not going to violate copyright, that certain types of models that you are building have to actually have license within the EU in order to be deployed, and they will want to have a look at what you've built. By the way, for anyone just doing finite state machines and behavior trees, as far as the EU is concerned, that isn't AI. You're gravy. Like, it's all good. Like, if you're just doing game AI, it's like whatever. But if you're using generative AI and some forms of deep learning, you need to be aware of this. And critically, even if you didn't build it, if you're part of a dev team who's shipping that project, you need to, in order to achieve compliance with the AI Act, be sufficiently trained on understanding what this technology does, because you're part of a team that's deploying that model into the market. Okay, that's one thing. We also have the Online Safety Act coming up, and that's also getting impacted by this as well, because it's tying into a lot of toxicity, AI technologies, and matchmaking. And last thing, just like generative AI has a pretty bad image right now, and much of that is highly justified. So, like I say, if you are going to be working in these technologies and are thinking of shipping a game with these technologies, these become your problem. And so really what I'm trying to stress here, you need to be ready to have answers for platform holders, for governments, and then also critically, given the current state of the consumer view, your customers as well. So the big takeaway is, for the love of God, if you haven't got a lawyer, find one. And if you have one, go have coffee with them as soon as possible. Okay? So just to quickly wrap up, like I say, AI for games is far more than bad guys and generative AI, but we really need to be approaching these tools with caution. Please do your research on whether a tool will cause you more harm than good, whether it's going to accumulate massive amounts of tech debt and the like. And also, just you need to keep an eye on this. This landscape is continuing to change very rapidly, and it's also going to evolve even further in the coming months and years. And I think collectively we need better information on this and to do more knowledge exchange. So naturally, I'm very excited for the talk right after this. I'm looking forward to hearing this. Do your research, seek legal advice where you can. Thank you very much. This has been a bit of a whirlwind. I'm going to be sticking about. Grab a shot of that. I'm going to be sticking about for the next talk, but I'll be about after that if anyone wants to come and have a chat. Thanks very much. Whew.